A green glow appears in photographs taken during this September 7th total lunar eclipse. 3I Atlas, the interstellar comet racing through our solar system, suddenly displaying an emerald hue that shouldn't exist. Headlines scream alien technology. Social media explodes with speculation. Harvard professors calculate 30 to 40% odds it's extraterrestrial. But here's what nobody's telling you about that green light. The chemistry doesn't add up. The molecules responsible aren't there. And the whole story is way stranger than aliens could ever be. You're looking at an object that traveled for billions of years through the frozen darkness between stars. It entered our cosmic neighborhood on July 1st, 2025, spotted by the Atlas telescope in Rio Hurtado, Chile. Moving at 61 kilometers per second, 140,000 miles per hour, coming from the direction of Sagittarius. The Minor Planet Center confirmed it within 24 hours, third interstellar visitor ever documented. After 1 Oumuamua in 2017 and 2 I Borisov in 2019, astronomers thought they had the playbook figured out. They didn't. Also comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the Very Large Telescope spectroscopic observations published in the Proceedings of the National Academy of Sciences in December 2021, confirming the dicarbon photodissociation mechanism in the ARC's preprint server paper by Hugendam and colleagues from October 15, 2025, detailing the Keck 2 telescope observations of nickel and cyanide spatial profiles around 3 the Marne Atlas. These aren't Wikipedia summaries, these are primary astronomical papers with pixel-level data analysis. Now back to the information. Miguel Alarcon's team at the Instituto de Astrofísica de Canarias confirmed the same day using the 2-meter twin telescope at Teide Observatory. Reddish coma, dust grains several micrometers across, classic comet behavior. Then the color started changing. Michael Yeager and Gerald Riemann captured images in early September. Green glow around the nucleus. Should be simple. Every astronomy textbook tells you why comets turn green. Diatomic carbon, C2 molecules, 2 carbon atoms bonded together in the coma. Sunlight hits them. Ultraviolet radiation excites the molecules. They fluoresce, emit light at 516.5 nanometers, green wavelength, swan bands. First reported in 1868 by William Huggins observing Comet 2. Astronomer Gerhard Hertzberg theorized the mechanism in the 1930s, predicted that photodissociation would break up C2s before it reached the tail. That's why comet heads glow green but tails never do. 90-year-old theory. Proven in the lab in December 2021 by Timothy Schmidt's team at the University of New South Wales. Published in PNAS, they used ultraviolet lasers to strip chlorine from tetrachloroethylene molecules. Created pure dicarbon, bombarded it with high-intensity light. Measured the photodissociation. The molecule absorbs 2 photons. First photon kicks it to a semi-stable state. Second photon destroys it completely. Lifetime at Earth's distance from the Sun, less than 2 days. That's why the green stays near the nucleus. Physics checks out. Chemistry verified. Case closed. X-shooter instrument covering 300 to 550 nanometers. UVES instrument at 35,000 to 80,000 spectral resolution. Looking for dicarbon emission bands, looking for tricarbon, looking for amino radicals, nothing. MDM Observatory in August, same result. No C2, no C3. Luis Salazar Manzano at the University of Michigan published findings. 3. IATLAS ranks among the most carbon chain depleted comets ever studied. The molecules that cause green glow are absent, but the comet is glowing green anyway. IFL Science reported the color shift on October 2nd, 2025. The comet appeared reddish when discovered in July, turned green in September. Spaceweather.com published photographs. Observers worldwide confirmed. The emerald tinge intensified as it approached the sun. Standard explanation: dicarbon fluorescence. Standard chemistry: molecules not detected. Something else is making that light. Mass loss rate: 17.6 grams per second by August 21st. Steep heliocentric distance scaling. Production rate increases as distance from sun decreases. Power law dependence. QCN proportional to heliocentric distance to the negative 9.38 power. That's abnormally steep. Most comets follow gentler curves. Avi Loeb suggested on his Medium blog, August 25th, that the green color stems from cyanide production. Cyanogen can emit invisible spectrum. But here's the problem. Cyanide chemistry actually supports the absence of carbon chain molecules. CN presence doesn't explain C2 absence. They should coexist. In 3, IATLAS, they don't. First metallic emission observed. By August 21st, nickel production rate, 4.6 grams per second. Only nickel, no iron. Every other comet observed shows nickel and iron together, roughly equal amounts. Same sublimation temperatures, same parent molecules breaking apart. 3. I Atlas violates that pattern. Keck 2 telescope observations from August 24, 2025. Willem Hugendam's team using the Keck Cosmic Web Imager, narrowband imaging at 386.5 to 388.5 nanometers for nickel. 360.5 to 362.5 nanometers for cyanide. Spatial profiles show nickel concentrated near the nucleus. Cyanide extends farther out. Nickel to cyanide production ratio higher than 2I Borisov. Orders of magnitude above solar system comet median. On Earth, nickel without iron only appears in industrial alloys. Carbonyl chemical pathway, nickel tetracarbonyl formation and decomposition. NiCO4. Industrial refining process, happening naturally on an interstellar comet. James Webb Space Telescope observed 3 eyes. iAtlas on August 6, 2025. Near-infrared spectrograph instrument. Detected carbon dioxide dominating the coma. CO2 to water ratio, 8 to 1. 95% carbon dioxide, 5% water by mass. Martin Cordner at the Catholic University of America called it among the highest CO2 ratios ever seen in any comet. Solar system comets are water-rich, ice balls with some carbon dioxide mixed in. 3. iAtlas flips the script. Dry ice ball with traces of water. CO2. Sublimation threshold, 148 Kelvin. Water ice, 273 Kelvin. Carbon dioxide starts vaporizing much farther from the sun. That's why the comet became active beyond Jupiter's orbit, 5 astronomical units out when most comets stay dormant. Stephanie Millam at NASA. Goddard Space Flight Center proposed a cooked shell theory. Cosmic ray radiation over billions of years created surface CO2. Now heating from the sun releases it preferentially. A spectrophotometer for the history of the universe, epoch of raionization and ICES Explorer, mapped the carbon dioxide coma, extends 348,000 kilometers in radius, only visible in near-infrared. Angular diameter in July, 2 arcseconds for the visible coma core, 10 arcseconds for full extent. Pre-discovery observations by Vera C. Rubin Observatory. Coma diameter grew from 13,040 kilometers on June 21st to 18,760 kilometers on July 2nd. Active and expanding. Hubble Space Telescope imaged on July 21st. David Jewett at UCLA led observations. Wide field camera 3. Teardrop-shaped cocoon of dust. Nucleus diameter estimate between 320 meters and 5.6 kilometers. Most likely less than 1 kilometer. Small body producing massive coma. Dust ejection rates in July, 6 kilograms per second for small particles, 60 kilograms per second for large particles, 150 kilograms total mass loss per second by late August when including gas. For context, that's like a fire hose at full blast running continuously. A small nucleus shouldn't sustain that rate, but it does. High negative polarization at small phase angles. Light reflected from the coma oscillates along the Sun-Comet observer plane. Behavior similar to trans-Neptunian objects, mixture of icy and dark material, tholins, irradiated organic compounds. Reddish color when first discovered matched this chemistry. Then the green appeared. Observed in dozens of solar system comets. Comet Leonard in December 2021, Comet Lovejoy in 2014, Comet Neowise in 2020, same mechanism. C2 photodissociation, lifetime of 2 days. Green coma without green tail. 3. iAtlas displays the visual signature without the molecular cause. Different chemistry producing identical appearance, or chemistry happening below detection thresholds, or something else entirely. Molecular combinations producing similar wavelengths under unusual conditions. Cyanide compounds fluorescing differently in low temperature, high CO2 environments. No confirmed mechanism yet. Chemistry remains unexplained. The green glow photographs from September 7th exist. Multiple independent observers, Gerald Rehmann in Austria, Michael Jaeger using backyard telescopes, amateur astronomers worldwide. The light is real. The molecules aren't there. Extension pointing toward the sun, not away. Keck observations from August 24th confirmed. Anti-solar tail structure, nickel and cyanide emissions extending both solar and anti-solar directions. Normal cometary tails point away from the sun. Radiation pressure pushes dust and gas outward. 3. iAtlas violates expectations. White light images show no prominent dust tail despite active outgassing. Material not behaving as predicted. Published paper July 16th with Adam Hibbard and Adam Crowell. Title, Is the Interstellar Object 3 iAtlas Alien Technology? posted on ARF preprint server, not peer-reviewed, lists 9 points suggesting artificial origin, orbital plane within 5 degrees of ecliptic. Probability less than 0.2%. Close approaches to Venus at 0.65 astronomical units, Mars at 0.19 AU, Jupiter at 0.36 AU. Cumulative probability 0.005%. Earth and comet on opposite sides of Sun at perihelion. Perfect position for clandestine maneuver. No spectral features of cometary gas in early observations. Opportunity for Oberth maneuver at perihelion or Jupiter flyby. Paper states consequences could be dire for humanity. Defensive measures possibly required. Loeb gave the object a 6 on his self-created scale. 0 equals definitely natural. 10 equals definitely technological. 60% chance of non-natural origin in his assessment. Told media outlets 30 to 40% likelihood. Changed as new data arrived. August 5th blog post on Medium. Continued emphasis on anomalies, lack of cometary tail, fine-tuned trajectory aligning with planetary orbits. October 15th stated mass constraints suggest either rarity or artificial origin. If nucleus larger than 5 kilometers, natural origin untenable. Nickel without iron matches, industrial alloys. Live Science reported overwhelming consensus. Natural comet. Many researchers disappointed with the speculation. Scott Manley pointed out statistical flaws. David Kipping identified errors in trajectory analysis. Daryl Seligman led first published study. Classical signatures of cometary activity clearly visible. Chemical detections will come as object gets closer to Sun and instruments become more sensitive. Original 10 to 20 kilometer estimate based on brightness. Ignored that brightness comes from coma, not nucleus. Loeb later revised to 1.2 kilometer nucleus, if natural comet. Wright noted that was obvious from the beginning to planetary scientists. August 6th follow-up. Hubble images show massive asymmetric coma. Looks like a comet, moves like a comet, outgasses like a comet. Duck test. Loeb kept spacecraft hypothesis alive by demanding all criteria satisfied, including anomalous orbit and specific gas detections. Interview with Interesting Engineering, published October. 3. I-Atlas is a comet. Always obviously been a comet. High carbon dioxide relative to water matches. Expectations for objects forming in different stellar environments. Loeb thrives in post-truth attention economy. Doesn't follow scientific method, doesn't exemplify the process. Martin Reist at Cambridge. Keep minds ajar to alien artifacts possibility. Search is worthwhile, but more skeptical and less credulous than Loeb. Submitted paper addressing alien claims, not yet peer-reviewed. Addresses orbital alignment. Retrograde plane near ecliptic, not impossible for interstellar objects, even if statistically rare. Natural explanation sufficient. No radio emissions detected. Allen Telescope Array at SETI Institute began monitoring July 2nd. Whale-Farah leading observations. Narrowband and natural emissions. No technological signals. No artificial light. No maneuvers. Trajectory follows pure gravitational path. Non-gravitational acceleration nearly 0. Richard Clote, Peter Veer, and Loeb analyzed 4 months of optical measurements. Minor planet center data. Compared position to gravity-only trajectory. Found negligible deviation. Mass estimate, minimum 33 billion tons. 1,000 million times more massive than Oumuamua and Borisov. But still consistent with natural comet if large enough. Colin Wilson called it impressive contribution despite object being 100,000 times fainter than usual targets. Mars reconnaissance. Orbiters, high-rise camera scheduled, 30 km per pixel resolution, 3 times better than previous images. Could separate nucleus from coma contributions. Data expected for public release soon. Data transmission delayed until February 2026 due to position. NASA's Juno spacecraft scheduled March 2026. Another close approach opportunity after Jupiter encounter. Europa Clipper coordination considered. Twin ultraviolet spectrographs. Both spacecraft observing different wavelengths simultaneously. This investigation uses spectroscopic data from VLT, published in Astrophysical Journal Letters, 2025, volume 990, issue 1 by Puzia and colleagues, plus the Penis, December 21st, 2021 paper by Borzowski and team proving the dicarbon photodissociation lifetime. At 105 seconds, not textbook summaries, but actual wavelength measurements and molecular bond dissociation energies calculated to 1 part in 20,000 precision. Back to the evidence. Detection limits might be hiding trace C2 below instrument sensitivity. Different observing techniques could reveal presence, more sensitive spectrographs, longer integration times, specific wavelength targeting, or entirely different molecule responsible. Chemical processes unique to interstellar formation environments, exotic ice compositions from another star system, radiation processing over billions of years, creating compounds we've never encountered. Orbital dynamics calculated backward came from Milky Way's thick disk, population of older stars. If thick disk origin confirmed, comet could be 7 billion years old, older than our solar system, formed around a different star, ejected during planetary system formation. Gravitational perturbation from giant planet, kicked into interstellar space, wandered the galaxy for eons, happens to pass through our neighborhood now. Random chance, or formed in thin disk, younger population. Either way, chemistry reflects protoplanetary disk conditions in another stellar system, different elemental abundances, different temperatures, different radiation environment. Beyond CO2 ice line where carbon dioxide condenses, but water remains gaseous, comparable to Kuiper belt conditions in our system, but with different ratios. Or cosmic ray processing created CO2 layer over time. Gardening effect, surface constantly bombarded. Volatile molecules broken and reformed. Preferentially creates carbon dioxide, surface shell enriched while interior remains pristine. Breaks apart easily under UV light. Releases nickel atoms and carbon monoxide. If dust grains contain nickel carbonyl, explains early metal detection. Explains iron absence if iron carbonyls less stable or less abundant. Industrial process on Earth, discovered 1890. Ludwig Mond in England. Purifies nickel through carbonyl formation. Nature apparently uses same chemistry. First time observed on astronomical object. Power law with negative 9.38 exponent means doubling solar input increases cyanide by factor of several hundred. Extreme sensitivity, parent molecule likely hydrogen cyanide ice or more complex organic. HCN sublimation temperature, 230 Kelvin. Should start vaporizing closer to sun than current distance, but observed already at 2.85 astronomical units. Another anomaly, unless parent molecule is different. Polymerized HCN, adenine precursors, complex organics with lower sublimation points. Chemistry team at MIT studied dicarbon perturbations. Robert Field, Jun Jiang, valence hole electron configurations. Dicarbon has surprisingly intricate electronic structure despite simple composition, 2 carbon atoms, but quantum mechanical behavior shows strident anomalies. Spectroscopic perturbations break regular patterns. Field spent 40 years studying molecular misbehavior, started with carbon monoxide deviations. When molecules misbehave, leads to great insight. Accidental discovery during acetylene experiments. High power UV laser, molecule blows apart. C2 emits light from highly excited states. Irregular vibrational energy levels, strongly perturbed by mysterious electronic state. Herzberg's garbage, deviations that pioneer spectroscopists set aside for future study. Perturbations affect photodissociation and predissociation properties. Determine survival time in sunlight. Explains comet color difference between head and tail. Puzzle solved in 2021 after 90 years. 3. iAtlas reintroduces that puzzle. Green without the molecule. Swift Observatory ultraviolet observations. July 30th and August 1st at 3.51 astronomical units. Hydroxide ions detected. Implies water vapor present. Rate 1.35 times 10 to the 27th molecules per second, roughly 40 kilograms per second. Combined with carbon dioxide loss, total mass loss over 150 kilograms per second. Sustained rate for months. Nucleus must have substantial mass. Minimum diameter, ½ kilometer. Maximum 5.6 kilometers. Most likely around 1 kilometer. Density estimates 1 to 2 grams per cubic centimeter. Porous ice structure. Nucleus mass between 500 million and 70 billion tons. 3. iAtlas at upper mass range. Never threatens our planet. Closest Earth approach. December mid-month at 1.8 astronomical units. 270 million kilometers. Still far away. After perihelion, object swings past Jupiter in March 2026. Gravitational interaction might slightly alter path, but no capture. Hyperbolic orbit, eccentricity 6.143. Unbound from Sun, will leave solar system, never returning. One-time visitor. Legacy survey of space and time, expected to discover dozens per year once fully operational. 3. iAtlas. Nearly discovered 2 weeks early during science validation. More objects mean population statistics. Understand formation conditions across the galaxy, chemical diversity, size distribution. Orbital characteristics. 3. iAtlas gives preview. Each interstellar visitor teaches us about different stellar nursery, different chemical evolution, windows into exoplanetary system formation. Cigar shape, unusual acceleration. Loeb claimed light sail technology. Most astronomers disagreed. Outgassing explanation fit data. Tumbling motion, asymmetric shape, Small jets produce thrust, no need for aliens. Media love the controversy. Attention economy rewards bold claims. Scientific rigor gets less coverage. Pattern repeats with 3-eye atlas. Unusual chemistry, unexplained green glow, anti-solar tail, high mass, low orbit probability, stack enough anomalies, seem suspicious. But comets are inherently strange. We've studied fewer than 10,000 solar system comets, only 3 interstellar visitors. Sample size too small for confident predictions. What seems anomalous might be normal for objects from other stellar environments. Based on science fiction novel by Liu Cixin. Premise? Universe contains many civilizations, finite resources, unknown intentions. Any civilization might preemptively attack others before becoming threat. Silence recommended for survival. If 3. I-Atlas were hostile probe, strategic approach makes sense. Surveil from distance, avoid detection. Deploy secondary probes when hidden by sun, speculative scenario. Entertaining thought experiment, 0 evidence supporting it, no signals, no maneuvers, no anomalous acceleration. No artificial structures, behaves like icy rock under solar heating. Occam's razor favors simplest explanation, natural comet with unusual chemistry. Someone claiming teapot orbiting between Earth and Mars can't demand others disprove it. Responsibility lies with claimant to provide evidence. Loeb's hypothesis testable in principle. Continued observations will reveal truth. If technological, should show signs. Course changes, radio transmissions. Artificial light, structural features inconsistent with ice and rock. If natural, chemistry will eventually make sense. More data clarifies composition. Detections confirm molecular inventory. Green glow mechanism identified. Multiple telescopes confirm cometary activity. Hubble shows classic teardrop coma. Gemini observatories capture tail development. VLT spectroscopy detects gas emissions. JWST maps CO2 distribution. SphereX reveals extended atmosphere, all consistent with active comet. Unusual composition doesn't imply artificial manufacture. Reflects formation environment differences. High carbon dioxide suggests cold formation region or surface processing. Nickel without iron indicates carbonyl chemistry. Steep production curves mean temperature-sensitive volatiles. Green color remains puzzle, but doesn't require aliens. Missing piece of chemistry we haven't identified yet. Forces consideration of all possibilities. Ensures data collection continues. Instruments observe wavelengths they might otherwise skip. Radio telescopes monitor for signals. High-resolution imaging planned. Comprehensive chemical analysis. Whether proving natural origin or discovering something extraordinary, science wins. Knowledge advances. But premature conclusions harm public understanding. Media amplifies unlikely scenarios, creates confusion about scientific consensus, distracts from genuine discoveries. 3. I-Atlas offers unprecedented opportunity to study interstellar material. Chemistry formed light years away. Evolution over billions of years. Comparison with solar system objects. Each measurement teaches something new. Focus should remain on actual science. October 15th, 2025. Latest Keck data published. Hugendam's team. Spatial profiles confirm nickel concentrated centrally. Cyanide extends farther. Anti-tail structure verified. Total mass loss, 150 kilograms per second. Water at 40 kilograms. Carbon dioxide and other volatiles making up rest. White light images still show no prominent dust tail. Contradiction remains. Active outgassing without typical tail formation. Either dust grain size distribution unusual, or radiation pressure dynamics different than expected. Or viewing geometry creates illusion. More observations needed. Post-perihelion observations reveal how solar radiation affected nucleus. Surface changes, volatile depletion, activity evolution. Comparison with pre-perihelion data shows trends. Chemistry may shift as different ice layers exposed. Deeper material outgasses, compositional gradients revealed. Green color question remains open. Dicarbon absent in spectroscopic observations. Visual appearance suggests dicarbon fluorescence. Either detection limits inadequate or different mechanism responsible. Cyanide fluorescence possible, but wavelength mismatch. Should appear more blue-green. Photographs show pure green, 516 nanometer emission. Characteristic of C2 swan bands, but molecule not detected. Paradox persists. Answer likely involves observational sensitivity or exotic chemistry. Time will tell. Interstellar objects as probes of galactic chemical evolution. Each visitor samples different formation environment, different star metallicity, different disk temperature profile, different radiation history. Building statistical sample reveals trends, correlations between composition and origin. 3. I-Atlas high, Keo 2 suggests certain formation conditions. Future visitors with different ratios expand understanding, eventually construct a map of chemical diversity across Milky Way. Planetary system formation, universality tested. Our solar system typical or unusual? Chemistry everywhere, similar or highly variable? Questions answered through interstellar archaeology. Next generation space telescopes planned, improved spectroscopic resolution, broader wavelength coverage, interferometric capabilities. Each improvement brings better data. Understanding deepens. Mysteries like 3 high. Eye Atlas green glow eventually explained. Meanwhile, November 2nd, 2025, JWST scheduled for additional observations. Near-infrared spectroscopy targeting methanol, formaldehyde, methane, ethane, hydrogen cyanide, ammonia. Detailed chemical inventory. Martin Cordner's objective. Revelatory comparisons with solar system. What molecules present? What absent? Ratios between species, temperature profiles, spatial distribution. Data reveals formation, environment clues. Answers, questions about protoplanetary disk chemistry light years away. Ariel Graykowski coordinates observations. Small telescopes 3 to 4.5 inch aperture. Image stacking compensates for rapid motion. Brightness measurements track activity evolution. Steep increase observed, consistent with dynamic new comet. Sublimation of pristine volatiles. Unaltered since formation. Probe primordial interstellar materials. Amateur astronomers worldwide contribute. Data submitted to Minor Planet Center. Professional researchers incorporate into studies. Democratization of astronomy. Anyone with equipment can participate in frontier research. The green glow photographs exist. Multiple independent confirmations, not camera artifacts, not processing errors. Real light at specific wavelength. Requires explanation. Current models insufficient. Dicarbon mechanism proven for solar system comets. Doesn't apply here. New mechanism needed. Or old mechanism in unexpected conditions. Chemistry operating differently under extreme CO2 dominance. Low temperatures. High radiation exposure over eons. Variables we haven't explored. Laboratory experiments planned. Simulate interstellar conditions. Test fluorescence of various compounds. Identify alternative pathways to green emission. Just nature being more complex than current models accommodate. Universe constantly surprises. Each surprise teaches. Knowledge grows through confronting what doesn't fit. Anomalies drive progress. This particular anomaly remains unsolved. For now. What we know for certain, object came from interstellar space, confirmed by hyperbolic trajectory and high velocity. Displays cometary activity with coma and indications of tail. Composition dominated by carbon dioxide with traces of water, carbon monoxide, carbonyl sulfide. Emits cyanide and nickel without iron. Shows green coloration in photographs. Lacks detectable dicarbon molecules in spectroscopic observations. Antisolar tail structure present. Mass likely tens of billions of tons. Nucleus diameter probably near 1 kilometer. Will reach closest approach to Sun October 29th, pass Earth vicinity December, encounter Jupiter March 2026, then exit solar system forever. How nickel carbonyl chemistry operates on cometary surface. Whether formation occurred in thick disk or thin disk, precise age, detailed internal structure, full molecular inventory, evolution over billions of years in interstellar space, reason for antisolar tail, dust grain dynamics. Mass loss sustainability given small nucleus. Dozens of questions remain. Each observation brings answers. Each answer raises new questions. Scientific process continues. Overwhelming evidence supports natural comet origin. Unusual doesn't mean artificial. Different stellar environments produce different chemistry. 3. Eye Atlas reflects conditions near another star billions of years ago. Chemistry we're unfamiliar with, not technology we can't understand. Distinction matters. Sensationalism undermines scientific literacy, creates false equivalence between speculation and evidence-based conclusions. Responsible communication separates hypothesis from confirmation. Loeb's papers clearly state most likely outcome is natural object. Media headlines often omit that context. Balance requires emphasizing consensus while acknowledging open questions. Gravitational perturbations, arrived intact, provides direct sample of matter from beyond our stellar neighborhood. No spacecraft necessary to reach distant systems. Universe delivers samples to our doorstep. Free Eye Atlas third delivery, more coming. Each one teaches about galaxy beyond our local bubble. Chemical signatures of star formation, planetary disk evolution, long-term space weathering, dynamical ejection processes, interstellar medium interactions, data available nowhere else, value immeasurable. Might take years, might require spacecraft flyby with dedicated instruments, might need laboratory simulations under conditions impossible on Earth. But answer exists. Nature follows rules even when we don't understand them yet. Patience and persistence reveal truth. Meanwhile, object continues journey, swings around sun, slingshots past Jupiter, heads back into darkness. Won't be visible again after spring 2026. Brief window to study. Make every observation count. Gather every spectrum. Image every wavelength. Data will be analyzed for decades. Each pixel contains information about another stellar system. Lost opportunity never returns. Gaps in understanding don't justify leaping to aliens. Scientific method requires ruling out natural explanations first. 3. I-Atlas, natural origin. Supported by all evidence, cometary activity observed directly, chemical emissions measured, physical properties consistent with icy body under solar heating, no anomalies requiring technological explanation, high mass unusual but not impossible, trajectory alignment improbable but not unprecedented, green color unexplained but not inexplicable. Each so-called anomaly has potential natural explanation. Combined, they don't sum to aliens, they sum to interesting comet from unusual formation environment. Interstellar visitor carrying chemistry from light years away, billions of years old, moving at speeds incomprehensible to human experience, glowing with light generated by quantum mechanical processes. Real science exceeds fiction. The reality: green means chemistry we're still figuring out. Dicarbon mechanism works for Comet Leonard, Comet Lovejoy, Comet Neowise, proven in Penis, December 2021, Jasmine Borsovsky and Timothy Schmidt at University of New South Wales. Vacuum chamber, 3 invisible UV lasers, tetrachloroethylene molecules, stripped to pure C2, bombarded with radiation, carbon atoms flying off measured to nearest centimeter across 200 meters of precision. Lifetime calculated, 90,000 seconds at 1 astronomical unit. Matches astronomical observations of other comets perfectly. Theory validated. But 3. I-Atlas doesn't follow the playbook. Different origin, different history, different chemistry, same visual result through different mechanism. Published in Astrophysical Journal. Dissociation, predissociation, and recombination of diatomic molecules. Photodissociation would destroy C2 before reaching tail. Green coma, colorless tail. Observation matched prediction for 90 years. 3. I-Atlas breaks pattern by showing effect without cause, or showing effect through alternative cause we haven't identified. Science advances by explaining exceptions. Past interest to next generation, Junjong continued work. Spectroscopic arcani, perturbations, predissociation, photodissociation, 3 concepts explaining color mystery in normal comets. 3. I-Atlas requires 4th concept. Unknown pathway, unknown molecule. Unknown conditions, creating familiar appearance. Field said, misbehavior leads to insight. 3. I-Atlas, misbehaving spectacularly. Insight forthcoming. Article titled, The Enigmatic Green Glow of Interstellar Comet. 3. I-Atlas, a challenge to our cosmic understanding. Emphasizes revolutionary nature of C2 depletion. Typical comets contain mixture of water ice, carbon-based molecules, various dust particles. 3. I-Atlas breaks mold. Abundant carbon dioxide, nickel, cyanogen, lacking molecules associated with green fluorescence. Chemical inventory suggests origin in markedly different environment. Strong depletion of carbon chain molecules implies vastly different chemical evolution path, or processing unfamiliar to us. Could reflect age or stellar environment where typical organic molecules scarce. Different astrophysical processes, sculpted makeup. Insights could revolutionize understanding of planetary system formation and interstellar chemistry. Presence of cyanogen and nickel hints at complex chemical processes in progenitor environment. Prominence juxtaposed with absence of typical green-emitting molecules invites speculation about alternative fluorescence mechanisms or unknown compounds fluorescing under solar radiation. Current detection limits mean C2 might lurk below threshold, or green hue arises from different molecule altogether. Puzzle intensifies, underscores powerful truth. Universe remains a vast laboratory of surprises. Details. Observations from Atlas and Pan-STARRS telescopes in Hawaii tracking rapid inbound trajectory. Very Large Telescope and Keck Observatory detecting volatile ices and organic material. Gemini North and South confirming color changes, first neutral, then greenish near solar heating. Points to outgassing chemistry involving diatomic carbon and cyanogen. Familiar in comets, but unusually strong at such distances. Hubble added ultraviolet and visible data, resolved faint jets, subtle accelerations unexplained by gravitational tugs. JWST infrared spectra shocked observers. Carbon dioxide and carbon monoxide emissions at levels inconsistent with expected thermal sublimation. Surface temperatures remained extremely low near absolute zero. NEOWISE mapped weak thermal signals. Greenbank Telescope and Meerkat radio facilities scanned. Tentative periodic modulation signal reported, still awaiting confirmation. Near absolute zero emissions explained by localized cryovolcanism or pressure-driven release of trapped volatiles. Exotic compositions expected from interstellar objects. Each measurement refines models. Chemistry from different star system naturally differs from local examples. Smithsonian Magazine, August 28th interview with Thomas Puzia. Quote, "We just cracked open the door to a whole new world of chemistry we never had access to before. High nickel and carbon dioxide abundance detected in coma. CO2 to water ratio among highest ever seen in any comet." Martin Cordner called it surprising. Object still far enough from Sun that detected activity level comes as surprise. JWST observations captured comet while distant. Stephanie Milam at NASA Goddard proposed cooked shell on surface. Floating through near absolute zero void for eons exposed to cosmic ray radiation. Developed surface layer where CO2 ice is created. Excess now heated by sun and venting into coma. Breaks apart easily when exposed to UV light. Releases nickel and carbon monoxide. May help account for high activity while still far from sun. Some materials left over from formation. If so, reveals where object formed within protoplanetary disk. Thick gas and dust around young stars where planets take shape. With more detailed JWST observations, astronomers hope to find additional gases: methanol, formaldehyde, methane, ethane, hydrogen cyanide, ammonia. Depends on what outgases. Objective, detailed chemical inventory. Revelatory as far as comparisons with our solar system. Favorite mechanism: ejected from protoplanetary disks of young systems forming around stars elsewhere in Milky Way. Population unknown, discovery rate uncertain. Rubin Observatory expected to increase detections dramatically. Statistical sample enables population-level studies. 3 myths dominate public discourse. First, green color proves alien origin. False. Green light indicates specific wavelength emission at 516 nanometers. Natural processes produce this wavelength. Dicarbon most common, but not only mechanism. Alternative chemistry under investigation. No evidence of artificial light source. No modulation patterns indicating technology. Pure fluorescence from molecular processes. Solar system comets range from water-rich to carbon dioxide-rich. Organic-rich to organic-poor. Metal-bearing to metal-depleted. 3. I-Atlas, extreme case but within natural variation. Formation environment determines composition. Different stellar nurseries have different chemistries. Absence of expected molecules doesn't negate cometary nature, just reflects different origin. Velocity and direction determined by ejection event billions of years ago. Gravitational interactions with planets along route create close approaches. 3. I-Atlas passes near Venus, Mars, Jupiter because orbital geometry happens to align. Millions of trajectories possible. Some intersect planet orbits, no targeting required. Probability low for any specific trajectory, but high that some trajectory will show close approaches. Selection bias. We notice and study objects passing through inner solar system. Miss objects passing through outer system undetected. Statistical arguments require accounting for observation selection effects. Quote from July 16th, our Civ posting. By far, the most likely outcome will be that 3 I-Atlas is a completely natural interstellar object, probably a comet, and the authors await the astronomical data to support this likely origin. Hypothesis presented as testable prediction. Interesting exercise in its own right, fun to explore irrespective of likely validity. Paper states consequences could be dire if hypothesis correct, but probability remains low. Burden of proof on those claiming artificial origin. Null hypothesis, natural object. Extraordinary claims require extraordinary evidence. Current evidence insufficient to reject null hypothesis. Loeb says 30 to 40% chance non-natural origin. Media reports a significant possibility. Scientific community says overwhelming evidence supports natural origin. Media reports as controversy. Public receives mixed messages. Confusion results. Distinguishing speculation from consensus requires careful reading. Primary sources versus secondary sources. Peer-reviewed publications versus preprints. Multiple independent teams versus single research group. Convergent evidence versus isolated claims. 3. I-Atlas, case study and scientific process. Discovery, initial observations, classification, detailed characterization, hypothesis generation, testing predictions, refining models. Each step builds on previous. Collaborations across institutions and countries. Shared data, open debate. Peer review, replication. Convergence on truth through iteration. Process works despite occasional false starts, self-correcting over time. Current status, natural comet with unusual composition, green color mechanism under investigation, alien hypothesis entertained but unsupported. Future observations will clarify. Assessing habitability of exoplanets requires knowing what materials delivered by comets. If 3I Atlas represents typical chemistry from certain formation environments, constrains expectations for planets in similar systems, high carbon dioxide, low water ratio affects planet surface conditions. Atmosphere composition, ocean formation, temperature regulation, chemistry drives habitability. Some will be comets, like 3I Atlas and 2I Borisov. Others might be asteroids like Oumuamua. Diverse population samples, different stellar environments across galaxy. Statistical trends emerge, correlations identified, universal principles versus local variations. Building comprehensive picture of Milky Way chemistry, one visitor at a time. Closest approach, 1.8 astronomical units, 270 million kilometers, safe distance. Future interstellar objects require monitoring. Most will pass harmlessly. Extremely unlikely one would target Earth, even if technological. Vastness of space makes Earth tiny target. Random trajectories vastly outnumber aimed ones. Sensible precaution. Track all objects. Assess trajectories. Calculate impact probabilities. 3I Atlas posed zero threat. Public fear-mongering irresponsible. Reading beyond headlines. Distinguishing possibility from probability. Scientific claims require evidence. Absence of evidence. Not evidence of absence, but also not evidence of presence. 3I Atlas shows green glow. Fact. Green glow caused by unknown chemistry, current understanding. Green glow caused by alien technology. Speculation lacking support. 3 different statements. 3 different levels of certainty. Conflating them creates confusion. Quantum mechanics governs transitions. Energy levels discrete. Fluorescence occurs when molecule absorbs high energy photon and emits lower energy photon. Difference goes into molecular motion. Dicarbon absorbs UV at 231 nanometers. He emits visible light at 516 nanometers. Green, other molecules absorb and emit at different wavelengths. Cyanogen in UV produces violet. Excited oxygen produces red. Sodium produces yellow. Magnesium produces green, but different shade. Detailed spectroscopy distinguishes molecules. 3I Atlas. Green matches, dicarbon wavelength, but dicarbon absent. Other molecule producing same wavelength or sensitivity insufficient to detect trace amounts. Either way, natural chemistry, no aliens required. High quality imaging and spectroscopy. Anti-tail confirmed, chemical abundances measured, spatial distributions mapped. No surprises suggesting artificial origin. All data consistent with unusual but natural comet. More observations scheduled, November space-based. December ground-based after solar conjunction, March Jupiter encounter. Each dataset refines understanding. Green glow mystery will be solved, patience required. Chemical composition, unusual but natural. Outgassing behavior, natural. No artificial signals, no technological structures, no anomalous accelerations beyond tiny non-gravitational forces from outgassing. Everything explained by comet model except green color mechanism. One unexplained detail doesn't overturn entire framework. Incomplete knowledge, not evidence of aliens. Evidence of incomplete knowledge. Science continues. Assumption follows. If green, then dicarbon. 3. I Atlas violates assumption, forces rethinking. Could be detection limits, could be alternative chemistry, could be something we haven't considered, but almost certainly not aliens. Occam's razor applies. Simplest explanation consistent with evidence, most likely correct. Natural comet with atypical chemistry, simpler than interstellar spacecraft disguised as comet. No evidence favors complex explanation over simple one. 2. I Borisov looked normal, similar to solar system comets. 3. I Atlas looks weird. Very different chemistry. Sample size 3 too small for generalizations. Need hundreds. Rubin Observatory provides. Meanwhile, study each visitor thoroughly. Extract maximum information. Compare with solar system objects. Identify commonalities and differences. Build comprehensive understanding of cometary chemistry across galaxy. Refinement coming. Process healthy. Dogma stifles progress. Flexibility enables growth. Current models work for solar system comets, need modification for interstellar visitors. Expected. Solar system represents one data point in galaxy of billions of stellar systems. Extrapolating from one to all, naive. Interstellar objects provide additional data points. Models expand. Understanding deepens. Science advances. Countless planets. Life arising elsewhere seems probable. Intelligent life possible. Technological civilizations conceivable. Contact unknown. Searching makes sense. SETI programs monitor radio frequencies. Optical surveys scan for laser pulses. Every interstellar object examined for technosignatures. So far nothing. Silence doesn't mean absence. Might mean we're looking wrong way. Might mean civilization's rare. Might mean they're quiet. Might mean we're early. Many possibilities. Keep searching. Use rigorous methods. Don't jump to conclusions prematurely. 3. I-Atlas. Not evidence of aliens, just unusual comet. Data accumulating. Answer emerging. Probably cyanide fluorescence under unusual conditions. Possibly trace dicarbon below detection limits. Conceivably, other molecule entirely. Unknown now, but knowable eventually. Patience and persistence pay off. Meanwhile, marvel at nature's complexity. Appreciate chemistry operating across light years. Celebrate human curiosity driving investigation. Science, at its best, asking questions, gathering evidence, testing hypotheses, reaching conclusions, admitting uncertainty, continuing search for truth. But myths debunked. Not aliens, not impossible, not inexplicable, just unexplained temporarily. Difference matters. Unexplained becomes explained through research. 3. I-Atlas, green glow will join solved mysteries eventually. Another triumph of scientific method. Another lesson about universe's complexity. Another reminder that truth exceeds imagination. Real cosmos more fascinating than fictional invasions. Keep watching, keep learning, keep questioning. Answers come to those who seek with rigor and patience. On October 16th, 2025, the green glow continues. 3. I-Atlas approaches perihelion. Maximum heating imminent, outgassing intensifying, observations ongoing, data streaming from multiple instruments, teams worldwide analyzing, papers in preparation, understanding evolving. No aliens detected, just nature being nature. Spectacularly, mysteriously, beautifully natural. The green light shines. Chemistry unknown, origin certain. Interstellar comet from beyond our neighborhood. Temporary visitor sharing secrets of distant stellar nursery. Gift from galaxy. Window into worlds we'll never reach. Worth celebrating for what it is, rather than imagining what it isn't. Reality suffices. 3. I-Atlas glows green for natural reasons. We're discovering one observation at a time.